Review questions. Electricity and Electronics 10th edition by Gerrish. Chapter 4. Define work. Is a force applied over a distance. Define power. It is the amount of work done based on a time period, such as seconds or minutes. What is the symbol for power? State Watt's law. Use it in a formula with a given voltage and current. When only 1 volt of electrical pressure moves 1 coulomb of electricity in 1 second, that is Watt's law. And in a formula, it is P equals current, or power equals current times voltage, such as 0.5 amps times 120 volts equals 6 watts. That's shown on your screen. By the way, the symbol for power is P. Compute the voltage and the power for the following. If power equals current times voltage through the formula, then we can solve this problem given the following conditions in a series circuit. Remember, a series circuit, we have 16 ohm resistor and a 3 amp load. So using the power formula, P equals I times E, power equals 3 times 16 in this case, 3 amps times 16 ohms, and the power equals to 48 watts. An electromechanical load is rated at 2,238 watts. What is the equivalent rating in horsepower, or HPs? 1 horsepower equals to 746 watts. So we can basically put it in a equation. X, which is the unknown, watts, divided by 746 watts, which is what we know a horsepower is equivalent to X amount of horsepower. So in this case, 2,238 watts divided by 746 watts will give us a total of 3, and that's 3 horsepowers. A car radio draws 1.5 amps when connected to a 12 volt battery or source. How much power is consumed by the radio? For that, we use the power equation, which is power equals current times voltage, which in this case is 1.5 amps times 12 volts, which gives us 18 watts. What is the difference between a wattmeter and a watt-hour meter? A wattmeter measures instantaneous power, and a watt-hour meter measures the amount of power used in a given time. When the dial pointer rests directly over a number on a watt-hour meter, how do you determine if the dial has truly reached that number, or if the value is still in the lower number? If the dial to the right of the dial is in question is between 9 and 0, then it is still in the prior number. A 240 volt 15 amp heater uses how many kilowatts of power? We can use the power formula. In this case, power equals 240 volt times 15 amps, which is 3600 watts or 3.6 kilowatts. Efficiency is a comparison of what two factors? That would be output power and input power. A fully loaded 230 volt 7 horsepower motor draws a current equal to 24 amps. What is the efficiency of this motor? We'll take a few steps to find this out. We lay it out as input watt equals to voltage times amps, which in this case is 230 volts times 24 amps, which is 5520 watts or 5,520 watts. To figure out the output watts, we know that 746 watts equals to 1 horsepower. Multiply that by 7 horsepower gives you 5,222 watts. To find out the efficiency with the information we've gathered so far, we make a equation again. Efficiency equals to output watt divided input watt, and you take that, multiply by 100, gives you the percentage. In this case, 5,222 divided 5,520, which is 0.9460. Multiply that by 100, gives you 94.60% efficiency. What is an EER? That is energy efficiency rating, which is often tested by the federal government for correctness. It is expressed as a percentage. Larger gears or pulleys can deliver more speed but requires more torque. That is the relationship of speed and torque in a pulley or gear system I'm describing. So the larger gear or the pulley can deliver more speed but requires more torque to turn it. Smaller gears or pulleys can deliver more torque but require more revolutions, therefore more speed. If you move 10 pounds a distance of 20 feet, you accomplish blank of work. Fill in the blank. Using the formula, force times distance equals work. In this case, 10 pounds of force times a distance of 20 feet. So it's 200 foot-pounds of work. What is the difference between power and work? Work is the force multiplied by the distance. And power is done during power is work done during a period of time. If you move 10 pounds a distance of 20 feet, you will accomplish blank work, blank of work. Fill in the blank. Again, using the formula. This is a problem that we've seen just now. A 2 horsepower electric motor is 50% efficient. What wattage is needed to operate the motor? And this is a curious question. The motor will consume, of course, 746 watts per horsepower. So it will consume a total of 1,492 watts. Since the motor is only 50% efficient, it will, however, output 746 watts of power. 1 horsepower is equal to how many foot-pounds per minute and how many watts? Fill in the blank. That would be 33,000 foot-pounds per minute and 746 watts. State Watt's law or Watt's equation and make it in all of its forms, possible forms. There are 3 forms shown on your screen. Are power equals current times voltage. Then we have voltage equals power divided current. Then we have current equals power divided voltage. Solve the following using Ohm's law and power formulas. Again, in figure 4-3 and 4-4 of your text, or if you have the memory device for Ohm's law and power laws is also available there. There are a few of these, so follow along. I won't be mentioning or reading as you can see. There are many of them. So just follow along the steps. Pause the video if you need to. If you have any doubts or concerns, revisit this chapter on the text and the review on the text.